One of the really nice things about using a BIM modeler for educational purposes is the realistic portrayal of the components and how that helps inform the student on how buildings actually go together. So you get a very realistic representation of actual building components. So I'd like to take a few minutes and kind of like do a kind of comparison so that what you draw and what you see in reality, just the relationships between the two. So you'll start to be able to visit construction sites, see other things in progress, and kind of really better understand what's going on. So our first part of this project is actually to build the foundation, and the steel structure. So I want to show you a few slides related to that. And it just so happens there's a similar building going on, going up. Actually, it's completed now in downtown Buffalo. Let me make myself a little smaller here. And it's a quite a unique place. It's a work sharing area, a co-working area where you can come in and rent spaces. I'm not exactly sure what the term is right now. It'll come to me. And I took some pictures of the construction of it because I thought it would be useful going forward. So we're going to make many similar components, and this is kind of like the skeleton beneath it. And one of the first things we're going to do, obviously, is create that steel work. And this steel work looks a bit different. One of the primary elements are these large pieces of steel coming down here, and these are going to be used to support the brickwork that's going onto the facade of the building. We don't use that in our project because our facades are lighter weight. We're not putting brick in that area. But if you would, this would be kind of the feature that would be added on the brick ledge to support the weight of those bricks, and that's happening up on the top and bottom. But then if you look back, you can see a lot of the same ideas about the way the steel structure is built here. There's also this relationship between a steel structure and a CMU, concrete masonry unit wall, which we will do in our project. And there's also, you can see this idea of an engaged column here. Actually, what I should do is make my pointer show up a little better. Um, you can see the foundation jutting out here in order to support this, what's called an engaged column. In our case, we're going to put a steel column in a similar way. And that's the current building as it looks right now. So I wanted to keep this in mind. I think this is actually a much nicer style. There's a few nicer features that are in this building. I probably would add them into our project. The parapet changes height at a certain point. The brick um, spandrel elements are really quite nice. Um, and then the idea of these single windows instead of all what is called storefront glazing. I also wanted to kind of, I had just down the street, another steel frame building going up. And I wanted to take this moment to kind of like bring up that idea of curtain wall that I discussed. We'll work on this later in the semester, and I'll probably bring this issue up again when we get to that point. But once again, a steel structure, actually kind of an interesting structure because as you can see, we got steel steel columns, steel floor joist, and then the infill is actually wood. So you can see there's wood in here making the rest of the floor decking. But the particular reason that I wanted to include this image for this presentation was this demonstration of what a curtain wall is. So you can see the building floor plates, the whole building is really supported by these vertical steel columns. And then the insertion here now of the curtain wall doesn't require, they're not taking any of the load of the building. They're just hung from the roof, in some cases fastened to the floor system. But the idea is that they're really just a curtain. They're no longer load-bearing elements. And we'll revisit this idea and concept, obviously, through your whole architectural education, but specifically in a few aspects of the projects we're going to do going forward. Also, I wanted to talk a little bit about this idea of our grid system that we're building. I take a lot of time to build this grid up. It both in the plan view and also a grid system in the vertical way. And this gets you into the idea of regulating sizes and shapes for a multitude of reasons. One of the reasons for setting up this 20 by 20 foot grid Was it made a relatively small scale building? It's conceivable that the building components like floor joist and that could span the 20-foot span without needing any kind of intermediate steel support. And that was just a way for me to simplify the kind of steel detailing we would do in this project. But also I ask you to make all these different levels, and I hope that as we go through it, you'll find how useful they are for assigning the components that we're going to discuss coming up. So in the first part of our project, we start to do this construction of the foundation. Once again, if you can remember back to the last image I showed you, the idea that there was this steel column sitting here, and how that foundation might be generated to deal with collecting that load from that steel column. Here we have an actual site um, foundation work. These are probably just the footers. We're talking about these short areas that are down below. There have been no walls added in. But it should start to become, after doing this drawing and thinking about what happens in a building, I think when you visit a site and you start to look at foundations being put in place like this, you'll have a much better understanding about what the intent is. It's very obvious that these are the starts of column systems because they have what's called reinforcing bar through the concrete footer. They'll probably continue up as concrete members. So these will be cast columns of concrete. But the idea of the odd shapes of trying to understand how a building footprint will eventually look, um, and trying to map that out in your head right now with no experience with making foundation systems can look very curious and random. But after going through the experience of doing a layout like this, eventually you'll be able to read kind of what's going on the site. And that kind of works back and forth to help inform you and educate you as an architect or a designer. When you visit another site, a little bit of information about techniques, the way things are built, that will help inform your designs going forward. I have a rich amount of projects that are happening in my neighborhood. That I can draw on for reference. This is another foundation system going in. And actually this foundation system out here is the footer for what will be a wall that gets poured in here. This is going to be a 5-story building, very typical to what architects do. This is would be called an infill building. This was a vacant lot before. For many years, it's next to what was the former Children's Hospital that moved down into the medical corridor. So a lot of new development happening in an older neighborhood called the Elmwood Village. And really quite impressive are these footers that are going to take and bear the load of the steel columns that are going to get fastened here. So we're looking at these large, massive footprints to distribute the load over the soil beneath it to carry the concentrated load of this column. So you can imagine this as just a very large pad to distribute the amount of weight that will be placed upon it by this steel column. And this is really quite unusual. But also the amount of just very interesting to think about what's going on in these construction sites. Actually, you can see the shadow of me taking the picture of it with the iPhone. This is the first story, so you can see the amount of excavation that happens. And then the need, here's the sidewalk. So here is shoring that needs to go up to retain the existing soil as they excavate out. This was also, interestingly, many years before, it was a former gas station. So all of the soil that was in here had to be taken out and remediated. You could actually, by walking by the site, you could actually smell the fumes of gasoline still from tanks that had leaked over the decades before. So a lot of activity in the project of building that you don't think about that needs to go into the planning process. And because we work with these models, we start to be able to grapple in our digital visual world with the things that are going to necessarily have to happen on site. So here's a much more simpler looking foundation system. Once again, like the pads that we're going to build our wall. And let me go back to this one. These are these pads here that are being placed. Oops, I went in the wrong direction, sorry. Are being placed in much more casual formwork. Many times the formwork for the footer is not as critical as the formwork that'll go up making the wall systems, because they need to be at least as large as they're specified to be. A little run in or run out on the wall system is really unimportant because it's just a pad that's going to bear weight on it. It just needs to be carefully aligned so that it lines up with the center of the wall. So this is just an opportunity for you to see what happens inside of this concrete. This is one of the things that doesn't happen when we model it all the time. We don't see this in our models that we're creating, at least not currently. And there are features eventually, like if you're looking to the image on the right, where when we draw foundation work, we can also set our rebar, reinforcement steel, inside of the concrete and get a visualization from it. But this reinforcement concrete helps to distribute the load that'll be placed upon the footings as the wall surfaces bear upon it. And these are coming up out of the ground here, and these are going to be used to tie the wall that gets constructed above it to the top of the footer so that it can't move out of position. Here's probably a better representation of what we're modeling and how it might look more in the real world. So in this case, we have our I-beams that are going across, which we are going to create, but we also have some differences. One of them is the vertical columns are not I-beams. They're actually square channels. I could have easily had us select those and place those in, but I wanted to keep more with a common kind of material that we were for the beginning. Who knows, maybe I'll change that up in future projects. The other thing is the infill is they have these what are called steel web joists to carry the floor load, and we're not actually going to place those in our drawing. This is maybe more similar to the kind of construction that we're doing. You can see the foundation work that's going in. You can see the steel I-beams that are, and I should call them right from the start, wide flanges, columns that are going in place to support the loads over the foundation system. And I said I-beam, and I actually said that incorrectly. When we talk about the steel that looks of this shape, as architects, we're typically talking about what are called wide flange beams, W sections. I-beams have a specific kind of shape to them, a taper to them towards the outside edge. When we're working in the world of structures for buildings, we're typically working with wide flange sections. So keep that in term W sections. I'm going to mention this probably, I'll mention it now, and hopefully you'll hear it many more times going along. We generally specify the size of these like you would a 2x4, except that the nomenclature is actually kind of significantly different. So here's an example. We have a wide flange beam, which is marked by a W. It's 27 inches high. And then the next number is not how long it is or how wide it is, but it's how many pounds per foot it weighs. And so what's important about that with these kind of I-beams, and this is really more information than you need in computer viz, but we're on that tack, and if you can pick this up, it'll be really useful for you. This idea of adding weight to these steel is a way to make them stronger. So the more steel we add, the more weight we add to a certain depth, the stiffer that beam becomes. So that covers the first part of M2, all of the components that we're going to be building. And in the next clip, I'll pick up on the components that we're going to be doing in M3.